So hello everyone, I'm Adrien Logut, tools programmer at Epic Games Montreal. Just a quick survey. Has anyone already played with PCG plugin in Unreal? Raise your hand. Okay, that's good, thanks. So today we're going to see how we can use PCG at runtime in UE5 by revisiting Snake with a PCG twist. So just a quick recap so that we are all on the same page about PCG in Unreal. This is a plugin that is available since 5.2 as experimental. It went out in beta in 5.4. It's a graph-oriented system based on the Unreal node graph. It has access to Unreal resources like landscape, actors, and it's also extensible, interoperable with every Unreal systems like geometry, script, Niagara, water, and it's available in editor and at runtime. So this is a very, very simple graph, like 4 nodes, just to do some scattering on the landscape. So you can query the landscape, then do some surface sampling that will scatter points on the landscape, random transformation with the transform point, and finally spawning some meshes with the static mesh spawner. And this is what you get. With a very simple 4 nodes, you can already have a lot of trees scattered around the landscape. So of course, PCG can do forest. I heard that PCG is a good scattering tool. We tried to break this, but of course, the obvious first use is to scattering trees, and that's what we did with the Electric Dreams demo, with this deep jungle environment, where the full map was, there was like a small case where the map was hand-placed, but the rest of the world was procedurally generated. And we also released the plugin called Biome Core to design biomes. So we already saw a few talks about biomes, so it will be pretty familiar to you. It will be the same principle. You have some biomes in your map, then you have some rules to scatter different objects around the map depending on the biomes. You can choose which type of trees, which type of rocks, whatever. And it's not limited to forest, of course. But it can do so much more. One thing that we introduced recently is like it's able to use Chef Grammar, sorry. You might have seen Chef Grammar in the Matrix Awakened demo. That's what we use to build the buildings and the city. So this is one kind of example that we have with the meshes from the Matrix Awakened demo. With a spline footprint, you can move it, and it's generate the building and adapt automatically. But we also released last Unreal Fest the Cassini sample that were in the space. With a space station, we have scattering props, and when we have like spline meshes for cables, we have geometry script interrupt to build meshes with PCG, and also like very high density scattering with an asteroid field. But most of it was editor only. So let's see how we can use PCG at runtime. So for this demo, what I wanted to do is I wanted to have something that is executed on the gameplay side. I want it to be impacted by gameplay element. If you run around, do stuff, it will change what PCG will generate. Be able to change the environment dynamically, but also have a simple gameplay because I didn't have a lot of time. So Snake was a classic game that allows me to do that. So the basic setup, I use the top-down view templates from Unreal. You have the character that runs automatically. It can grow and leave its trails behind it. It's a very simple Niagara effect that takes the pose of the character. If you intersect with the tail, you restart. And it's an infinite level. So usually when you do PCG at runtime, you combine editor generation, so offline generation and runtime generation. But for this demo, I wanted to do everything at runtime. So the ground is generated at runtime, the obstacles, the collectibles, the grass, etc., etc. This leveraged the PCG hierarchical runtime generation. So for those who are not familiar with it, the hierarchical generation is just a way of partitioning your bounding box on a grid, and you can have different levels of partition, more and more smaller, and you can generate the top, then the bottom, and etc., etc. And you can also combine this with runtime, where everything will be generated around the player with a given radius. So to set up yourself to use it, you have to go into the PCG graph, enable hierarchical generation. Then on the PCG component, you need to set partition and generate at runtime. And if you do this, it will only generate when you press play. So if you want to use it in editor and see what's going on, you have to go on the PCG world actor and enable treat viewport as runtime source. All right, so very simple first graph. This is to generate a tile world where I'm just spawning planes and we have a given material on it. It will be like on grid 512 meters. And you can see on the top, this is a very simple graph. I'm just generating point on the grid, assign a mesh to it, do some math computation to make sure that the plane is matching exactly the size of my grid, and then assigning a material to it, and then spawn it with the static mesh spawner. So to fill the world and to have some obstacles, the first obstacle will be trees. I say we didn't do forest, but that's exactly what I did. So, on the grid, I will be on the 128 meters, and it's just simply scattering trees around. One caveat on this is that we want to pull the position of the player, because if you are regenerating the world and you place tree exactly what the player is, it's not a good gameplay. So it's also a graph that is not that complex. If you do scattering, you already know about it. You can select either if you want to do raycast or use the landscape data in my case, go through a grid size for make sure that everything is generated on this grid size, which is 128. Some fast sampling. Doing the difference, so that's where I'm using the get actor data, just here. That will pull the player's position and you use as a difference to remove any points that is intersecting with the player bounding box. Random transformation, assigning meshes, and then spawning the meshes. You can see that I'm using, at the end, a create target actor node. Usually when you spawn component, they are attached to the same actor of the PCG component, but you can also attach them to any actor you want. And in my case, I wanted to have actors that have a given tag so I can interact with the trees later on. So that's why I'm creating a target actor that will just create a simple actor that will have a tag that I can use it later on. So this is what I have, just flying around the map. You can see that the ground is generating at further range, and then you have the trees. I'm just using some Quicksil Megascan for the trees, which is definitely overkill for this, but it looks good at least. And this is what you have when you just play the game. You're just running around, and then if you hit a tree, you just restart at the starting position. All right, so it's pretty empty with just the trees, so let's fill it with grass. The idea here will be to have two generations on two grids, one on the 128 and one on 64 meters. The idea is just that you will have a smoother transition when you are exiting the 64-meter range of generation. And then when you are at 64-meter range, you have more instances because you have the one from the 28 and the one from the 128 and one from the 64. It's exactly the same thing. I'm just repeating over and over again. Sampling the surface, assigning some meshes, do some random transformation, and then spawn them. So this is what we have. So it's densely packed with a lot of grass that you can see on the ground. You can see that the generation is smooth. It's definitely denser, close to the camera, and then you have some foliage that still appear further away, and then nothing, of course, when you have more trees. But if you take, I don't know if you see, it's probably pretty small, but you can feel that there's hitching when you are moving around. So it's important when you do some PCG that you know how to analyze and profile what you did. And especially when you are doing runtime, it's very important that the generation is fast and you don't have hitches. So we'll see how we can just try to analyze what's going on. So we have a profiler that is integrated into the PCG editor. So you can select a given PCG component and then see exactly which nodes are taking the most time. In my case, it's taking 11 milliseconds on the total time. And I'm pushing 30K instances at once. So it's pretty costly. And 11 milliseconds is for just a single cell, so that's definitely not a good experience because you will definitely have hitches at runtime. And you can see that Fast Sampler is taking 7 milliseconds, which means that the raycast is very costly. You have the static mesh spawner that is also 3 milliseconds. So everything that adds up, and at the end, that's why you have hitches. So one thing that we introduced in 5.5 was to be able to do custom HLSL nodes, and also so generating points directly on the GPU, and then push those instances from the custom HLSL node directly to the GPU scene. So we don't have any CPU readback. Everything is pushed directly to the static mesh spawner on the GPU scene. The HLSL node is just the compression of the graph I showed before, creating a grid, do some random transformation, and then assigning the mesh you're going to use. And this is what we have in the end, no more hitching. It's much fuller, even flying faster, and then it's still very stable. So there are a few caveats with GPU spawning. Of course, since it's only on the GPU scene, you don't have any collisions. So that's something that you need to be careful about. So for foliage, we don't care about collision, that's perfect. Also in 5.5, we don't have any support for ray tracing on the GPU meshes, but that's coming in 5.6. So now that we have our world filled, we need to add some gameplay elements. Since I'm a good artist, I'm going to use cubes for my props. So we're going to have like blue cubes for food. So when you intersect with the blue cube, they're going to grow. And we'll have also red cubes that will introduce variation. The idea is that each cube will contain information about the graph it needs to re-execute. And it will regenerate everything when you intersect with it. Same thing, surface, selecting a surface, then sampling the surface, then using a random choice to select a few points out of it, spawn actors that will be my blue cubes at the top, and then for the other points, I'm also getting another random choice. And at the bottom, you can see that I have the add attributes that is assigning to each point, it will assign with the match and set attribute, randomly points to each point, which graph is going to be used. So you have one graph for the trees, one graph for the grass, one graph for the ground. And those will be directly pushed to the blueprint that I'm going to spawn. So on the spawn actor, you can see that the spawn actor property overrides. I have 3 properties on my blueprint, and I will push the attributes from a PCG to the actor directly. So that's another way of interaction between PCG and the rest of Unreal, is that you can send information from PCG to the actors. Then I have like a simple logic on the blueprint. That's when I'm intersecting, I'm just going to read those values and then push the graph to the PCG components. One thing that is important when you do regeneration, especially at runtime, is that you want to flush the cache, because the cache results in PCG because we want to do to be fast and don't recompute something that we already computed. But if you change the seed, or if you change anything, you need to flush the cache so that we just try to recompute from scratch. And I have a function that just call set the PCG and refresh. So for the trees, what I want to do is I want to set the seed on the PCG component. So every time you intersect with a red box, you're going to regenerate the trees. So the trees will move places. Set the graph and also refresh the component at the end. And so this allows us to completely change the setup at runtime. So you can have a forest, and then when you intersect with a red box, you can just get transported directly into a junkyard with tires and more like a sand ground with rocks and everything. And of course, because I wanted to have some fun, it's that when you are going around and you are big enough, you can eat the trees. So that's another way of interacting with what PCG has generated. One trick is to take the instance and then move it away. When you have collisions, or if you do any raycast and you hit an instance static mesh component, you have the hit items that will give you the index of the instance in the component that was hit. And so I can update the instance transform by just moving it into oblivion to just make it disappear. If you remove instances, it's costlier because you have to move things around in memory, but if you just move it away from the camera, it's way cheaper. And that's one way of doing interaction with something that was spawned with PCG. You can imagine from, we'll be able to cut the trees. Like I can have an action that just cut the tree. And sometimes I just want to know that I cut the tree and I don't want to regenerate it what it was when I come back. So you can combine this with some kind of storage, persistent storage, when you just store the position of the trees that just was removed. And you can re-inject it in PCG afterward to make sure that the trees are not spawning at the same place. It's the same logic that I did for the player position. You can also push over point cloud for that. Another thing to show what we can do with PCG is to do some kind of pathfinding. And in my case, it's going to introduce mines. So it's just those small spheres that will be spawned at various places in the world. I'm using a very 2D grid, like generic grid, with a caveat is that you can see that they are all different gray scale color. It's because I've noised the density, and the density on the point is represented by the color. And the idea with the noise is that when you do pathfinding, it will do the shortest path, but you can input a heuristic into it, so the cost function can be slightly different. And if you introduce noise into this grid, it will just introduce variation in your path. So you won't have like a straight path to your goal. It can do a few variation and few turns. Also, the grid will remove the points coming from the trees, so make sure that the mine is not intersecting with the trees. So what I did is that from this grid, I'm just selecting two elements that are randomly chosen in my set. The first point, I'm going to spawn the mine on this, so that's going to be the target actor. Just I'm spawning a new actor at this position. And I'm going to do pathfinding on all the points between my start and my goal. This is outputting me a spline, and then I can push this spline directly to the actor I just spawned. And on the spawn spline component, you have the post-process function. That is a function that is on my blueprint. I can call after the spawning and do some preparation for gameplay. In my case, I will just read the new spline and just push to it, and then make the spline follow the mine follow the spline. On the pathfinding side, as I said, you can change the cost function mode with a fitness score, and I can put the cost attribute to be the density, so that the density will impact the score for the heuristic of the pathfinding, and we'll have this another straight line, bit of variation. Another thing would be the buildings. That's what I showed earlier with the Matrix Awakened assets. In my case, it's a simple building with simple textures and just boxes. It's available in the plugin contents, and you can go look into it. It's in the grammar sample example. And what I have for this is that I'm defining some modules with a symbol and also some mesh for each symbol. And I can have a grammar that you see at the bottom right, where I'm just putting a symbol C, then I have W and W1 that has a wall and a window, an asterisk that will say I will just repeat this as long as I can, and another C for the column, and it gives you this kind of building shape. And you can eat trees, but you can also eat buildings, of course. All right, so in summary, all our gameplay elements are spawned at runtime. We have the ground, we have the grass, we have the trees. We also have gameplay elements with the collectibles, the mines, the buildings, and all the grass was spawned with GPU microscattering, so to be like as efficient as we can. And of course, the gameplay can influence the generation with the red boxes. When you intersect with them, we have a regeneration and can even change the meshes that are spawned. All right, so we saw it's running on my big PC, but can it run on mobile? And can I play the video? Yep. And yeah, it does. I have it on my phone if you want to test it later. So of course we have a lot of trade-offs. You can see that the density is and the meshes are way lower quality, but it is still possible. And I'm sorry for the hitches. Recording on my phone and playing the game was making my phone kind of wanting to explode. So of course we have a lot of trade-off to run on mobile. We need to scale down the number of instances we push to the GPU. There is a hard limit on mobile. If I remember correctly, it's 250K instances. If you go past that, it will just crash. So we had to reduce the number of graphs we are pushing to the GPU from 15K per grid to 1.5K. And to do that, we can leverage the PCG quality branch node. You can see on the left, it is controlled by a CVAR. Unfortunately, it's not plugged to the scalability control, but you can set, when you set the scalability, you can also set the CVAR. And this is going to execute only the nodes that are downstream. So if you are in low or medium, you can go through my path for a low number of instances, which is 1,500 instances. And then if in high or epic, I can go through the bottom path and have like 15,000 instances. Unfortunately, for custom HLSL nodes, for when you generate points, the number of points you generate is static. So you need to have two different nodes for that. And of course, you saw that I was aggressive LODs because I use Megascan and they have one Gaussian triangle. So it wasn't going to work on mobile. So now a few things that are coming in 5.6 that will be improving the experience I just showed you. First thing is that scheduling and multi-threading will be better. The GPU nodes were taxing on the game thread, even if it was fast going on the GPU, just the preparation was long on the game thread. We also had problems with memory leaks for when we're just running around at runtime. So that's going to be fixed in 5.6. Also, we have out-of-frame execution. So when you have nodes that can be executed outside of the game thread, like sampling the landscape, you don't have to be on the main thread for that, and you don't have to wait for the main thread to tell you, oh, okay, you can go. No, you can just let it run, and then we have the result, we just get it back. We'll also have supports for landscape grass map, and this will make the GPU nodes able to sample the landscape grass map, and this will approach us close to what the foliage tool is doing, and so we'll be able to try to have the sampling directly on the GPU for the landscape grass map. Also, finally, a bit more technical, but we are switching how we are storing points underneath, going to a structured array. This will save a lot on the data copy because right now, it's in PCG, everything is constant, as all the inputs are constant. So when you do any modification onto the points, we need to copy all the points. And with the structured arrays, we will save on the copy a lot of time. And because of the data locality, if you are processing all the position of the point, for example, it could be also faster on the processing. But it's mostly on the memory saving that we have gains. So other ideas that I have for, I had for this presentation, but I definitely didn't have a lot of time. One thing that you have is dungeon generator. You can generate a new dungeon on play. You can also be evolving. If you are moving around the dungeon, exploring the dungeon, you can just change the rooms dynamically. I don't know if you played Kingdom Hearts Chain of Memories, but you can just use cards and it would generate a new room every time you go into a new room. So you can have this kind of non-Euclidean dungeons. When you exit the room behind you just gets deleted, and then you can just create a new room, and then it has a different sizes. So we can go crazy with that. Another possibility could be a PCG grenade, when you just throw a grenade, and then at the explosion point, you just scatter points and you spawn meshes or whatever. It could also be combined with Niagara or just chaos physics, so that you just let the particles settle on the ground, and then at the places where you have settles, you can just spawn stuff. And another thing could be like falling leaves. You can combine with the Niagara interrupt plugin that we have and Niagara data channels. So we could have trees that are spawned with PCG, and then the position, they know the position of all the trees. And then it can be used at runtime to spawn Niagara systems, and also can also be read the type of tree, for example, if you want to change the type of leaves that are falling down. If you want to know more, I have this big QR code that it's just the copy of just the text that you see on the left, because you cannot click the presentation. You have the Electric Dreams deep dive when we did with my colleagues Jean-Sébastien and Julien about Electric Dreams. The Cassini sample that was given also by Julien and Jean-Sébastien at the last Unreal Fest. You have also a YouTube channel when I give PCG tutorials, so don't hesitate to come and say hi. And the Unreal Source Discord, where there is a PCG framework channel there. I'm lurking them here a lot of my time. So if you want to chat with me or get in touch with me, you can also come to this Unreal Source. And when I will clean up my file, we'll also try to make them available so that the demo you saw will be downloadable. And thank you.
Okay, I see some hands already. I'll start from the back now.
Amazing talk, thank you. Are there any plans for more runtime geometry script interop?
Yeah, of course. The problem with geometry script and dynamic meshes in general is that it's expensive to run at runtime. They cannot be used with Nanite, if I remember correctly. So you can do it, definitely, but you will have to be mindful with the cost that goes with it.
Yeah, thanks for the talk. Can you partially flush the cache in parts of the graph, or does it always flush the whole thing?
Yeah, that's a problem. The cache has no knowledge of where this data was generated, so unfortunately, you cannot flush part of the cache. That will be something that we want to have at some point, because you don't have to recompute everything. So having knowledge about the cache will be good, but unfortunately, right now we can't.
Okay, and for vertex color and custom primitive data, can you pass that through PCG?
Can you put your mic?
Sorry, yeah, for custom primitive data and vertex color, can you pass that through PCG?
Okay, so yeah, you can. We have support for custom instance data per instance on the ISM, so instance static mesh component. Unfortunately, we don't have custom primitive data per component right now, so you need to push it to every instances. But we plan to have support also for custom instance data. And for vertex color, I don't think we can push right now directly, but you can read from it with the mesh sampler. You can read the vertex color.
Hi, thank you. Great talk. And I'm very glad that the Unreal users now have finally a way to do this in real time. It's really great. Nice. I want to ask a bit of a provoking question. Why? Like,
why?
Yeah, like I think most of the programmers in this room could remake this in 100 lines of code. It's not like 11 milliseconds. That's quite expensive, right? So I was wondering, like, how would you convince an outside user to now adopt Unreal and this blueprint system? Like, what is the advantage of taking this approach?
So taking the approach of the PCG instead of doing a blueprint? That's the question?
Right, or just writing like an application like this in another.
Okay, I see. Yeah, I mean, of course, the advantage of using Unreal is that you benefit from everything that comes with it. So if you want to do large worlds, you can use very high fidelity assets and everything. Of course, we don't have any good solution in Unreal to in-house to do PCG. It was heavily relying on Houdini, which we want to collaborate with, definitely, to have more interaction with PCG and Houdini. So yeah, I guess it's just if you want to have something that is we'll try to find ways that you do most of the stuff directly in Unreal. So you just reduce friction, and that you can see the results very quickly. And there was no solution for PCG at runtime you didn't have to build your own solution, basically. So that was also one of the motivation behind this plugin.
Yes, I have a question about the system in general, I guess, and how you would use it from a gameplay programming perspective. So I understand you can invoke it at runtime, obviously, but how is the system built to be able to be invoked, like, for instance, from parallel threads? Like, if you're generating a very large map and you say you have 30 towns, and each town you would have like an object scattering step for like inside the town for like placing buildings and props and clutter, and to like reduce load times if you're like doing live generation for a game map, you'd want to parallelize as much as possible. Is the system built to deal with that, or is it, you know?
I mean, you are if you know that you're going to have costly generation at runtime, you can hide it behind loading screens. And you don't have to do everything like in front of the player. We also have support for replication. So if you do any multiplayer game and you want to generate something that all the players will see, that's also a possibility. And we just build on top of what Unreal proposed for replication. So yeah, did I answer the question correctly, or do you want more? Okay.
Hello. Thanks for inspiring talk. And as you mentioned, like everyone perceives PCG as first of all, scattering tool, like for trees, but it's also very promising infrastructure for paneling, for generating like facades of buildings from prefabs. But for architectural objects like buildings and roads, sometimes it would be convenient not only to rotate and scale the instance, but also to shear or skew. It is not a problem from the 3x3 matrix, which like on the GPU works well, but does PCG allow to either transform by matrix or explicitly set the shearing? For example, to use the same instance asset for horizontal railing on the balcony and for the stair railing, which is skewed.
Yeah, I see. We pushed in 5.6 more operation on the metadata, so that, for example, for the roads, you could push custom metadata to the road on each control point, and you could control the width, and it could be impacted what the spline mesh you are going to use afterward for the deformation, how you're going to be impacted, and you can do some computation in PCG directly and then push it to the spline mesh. As for mesh deformation or for buildings or whatever, right now we don't have any good solution that is just hands-on, but with the support of geometry script, you can just do the shape grammar system to place the modules, and then you have a post-processing when you just analyze the angles between the different modules, and then you can just use custom geometry script to bend it if you need to adapt it to your shape. Yeah, and also like augment it if you want to have balconies, for example.
Hi, I had a question about at the start, you were talking about shape grammar and the custom geometry scripts and how they only worked at editor time, basically. And then at the end of the demo, you used those to generate the buildings for the Snake game. Was that running in real time, or were those like baked ahead of time, so you have multiple variations? How did that setup work?
Nope, everything was runtime. So the buildings were also generated at runtime. It was not a dynamic mesh. It was just like all the meshes stitched together. But there is no limitation of using dynamic meshes at runtime, as I said at the beginning. It's just that you will have a higher cost. In this case, the buildings are just blocks that I'm placing at runtime and just basic static meshes. So there are just a lot of them instanced.
All right, thank you.
Okay. Thank you very much for the talk.